All right, students, so we're back with special right triangles again, but this time we're talking about a different one. These were called 30, 60, 90 triangles. And if you're wondering why do we call them 30, 60, 90 triangles, well, stay tuned and find out. So it turns out the 45, 45, 90 triangles are not the only special right triangles. There's another type. We call these 30, 60, 90 because 1 degree is 30 and 1 degree is 60 and the other degree is 90. So this is actually a huge punchline, and this is why we know the things we know about 30, 60, 90s is this fact right here. Fact, every 30, 60, 90 triangle can be formed by dividing an equilateral triangle in half. So I'm going to take red to represent blood because we're going to kill this triangle by cutting it in half. Hiya. All right, I just cut it in half. It's dead. All right, now this was an equilateral triangle. So what does that mean? That means that this angle was 60, this angle 60, and this angle up here was also 60. However, some really cool things happened. All right, I created this right angle right here. That's the 90-degree angle. And then since up here, this angle up top, I cut it in half. That's 30 degrees. All right, so everything we're talking about with 30, 60, 90s, really we're just talking about half an equilateral triangle. All right, so based on this fact, we can really get a big punchline of, or some other things about everything else. Anywho, given that fact, well, let's just talk about something really fast before we even move on. Hypothetically, let's just say this number was 10. If this side was 10, remember this is an equilateral triangle, so the bottom is 10, and this right here would then be 5. All right, so already if we're given the hypotenuse, in 2 seconds we can figure out the short leg of this triangle. All right, and that's going to help us kind of really think about stuff moving forward. And then if we wanted to find this side, I'll call this x for fun. We're going to use Pythagorean theorem to solve for x, but that's what we're going to do moving forward, not right now. So here, given this facts, what is the value of x on the picture on the right? So right now we have the short leg. All right, what x is the hypotenuse. All right, so we have the short leg, we have the hypotenuse. Now let me do this. Remember, this is half an equilateral triangle. So I can hypothetically extend it out and say, well, then this is 60 and 60, well, so on and so forth. So remember, this was cut in half. So thinking about this entire base, if this is 4, that means this entire thing was 8 when we create the equilateral triangle, thus x is also 8. So really, all we had to do is say number 4, side length 4, to go from the short leg to the hypotenuse, all we have to do is multiply by 2, because short leg's half the length of the hypotenuse because we cut the equilateral triangle in half. So 8, the hypotenuse was 8. Now we're going to use Pythagorean theorem to find y. All right, so we're really just focusing on this stuff right here. I got a bunch of junk written down. All right, we're going to have y squared plus 4 squared equals 8 squared. All right, so then this is classic Pythagorean theorem, just a bunch of solving. So y squared equals 48. Take the square root of both sides.
Hello, hello.
All right, picking up right where we left off. That was Miss Madigan saying hi to me in the math office. But now y equals the square root of 48. All right, so remember we want the exact form right now, so we got to think, what's the largest square factor? So hopefully I don't have to write down these numbers. Hopefully you already can tell what it's going to be. But the largest square factor of 48 is 16. Remember, the square root of the largest square factor goes first, then the other number. So it's 16 and 3, which breaks down to 4 radical 3. All right, so that was it. All right, given the short leg was 4, long leg 8, or hypotenuse was 8, long leg was 4 radical 3. There's a definite pattern going on. We're going to do these 3 problems right here, very tedious. Very slowly, we're going to use Pythagorean theorem and brute force and find these legs, but after we know the pattern, It's only really going to take 2 seconds to figure things out. All right. So again, short leg. All right. We already know the pattern right here, times 2. The hypotenuse is 12. The short leg's half the hypotenuse. Now long leg, we'll call y again, because why not, LOL. But we're just going to use Pythagorean theorem to find the value of y, the long leg. And again, just a bunch of computations going on. So after I subtract 36 from both sides, y squared equals 108. Take the square root of both sides. Y equals the square root of 108, or y equals the square root of 108. What's the largest square factors of 108? And again, might take a while, but it's actually 36. And then radical 3, which breaks down to 6 radical 3. So given the short leg was 6, long leg was 6 radical 3, hypotenuse was 12. Okay, well, let's do that again. All right. Short leg is 10. So again, this SL means short leg. Immediately we know the hypotenuse is times 2, given the fact that it was a equilateral triangle. Now we'll call this y again, being real creative here. 10 squared plus y squared equals the hypotenuse, which is 20 squared. And then again, just doing a bunch of math, computations. Maybe you already know the pattern. There is a pattern going on, cheat codes, which makes all these problems take 2 seconds to figure out, if you know the patterns. All right, so y equals the square root of 300. Hopefully it's obvious what's the largest square factor here. It's 100. And then the other one's radical 3. So the final answer is 10 radical 3. All right, cool beans. And then this last one, a little bit of a challenge problem because it's giving me the short leg as radical 2. That's a little unusual, but nonetheless, the hypotenuse, you want to just multiply by 2, so the hypotenuse is 2 radical 2. And then we'll call this y. Y squared plus radical 2 squared equals 2 radical 2 squared. And again, major simplification going on. Remember, a radical, square root squared, they undo each other, so you're left with 2. Then we're going to have 2 squared and radical 2 squared. So I'm literally going to write that out just to make sure we're all on the same page. So 2 squared is 4. Radical 2 squared is 2. Again, a lot of computations going on. We're getting super close to being done. Y squared plus 2 equals 8. So y squared equals 6. Take the square root of both sides, and y equals the square root of 6. All right, so there's a pattern going on. All right. Do you notice a pattern? Explain in words and using patterns and symbols. So what this means is, first off, we were given the short leg. All right, this is important. This is what happens when we're given the short leg. All right, to figure out the hypotenuse, so SL equals x, the hypotenuse is just going to be 2x. It's double the short leg. Then to figure out the long leg, well, it's just x radical 3. It's whatever the short leg is, and then you incorporate a radical 3. And if we look at stuff, that's why in A, 6 radical 3. In B, short leg was 10. Then we had 10 radical 3. I could have wrote it over there as well. Over here, a little bit hard to tell, but radical 2 and then radical 6. Well, radical 2 times radical 3 is radical 6. So that's the pattern, using symbols, and then we'll even write it out just for a lot of fun. Hypotenuse equals 2 times the short leg, and then long leg equals the short leg radical 3. And you always keep the radical at the end. It just looks better. All right, so that's it for that. Stay tuned for more.